Alright, now finally 5-6. Let's be able to solve some polynomial functions and get some real answers and some imaginary answers. Let's look at that first problem right there. So, how they will phrase these questions, they'll ask you what are the zeros of that given quartic function that you see right there in front of you. Look at what step 1 says. Look familiar? Yeah, we saw this in the last two videos. Your first step is to graph that into your graphing calculator. Okay? And then what you're looking for when you graph in your graphing calculator is look for the integer real zeros. Okay? Look for the places where it crosses the x-axis, in other words. And notice on this particular problem, there are two places where it crosses the x-axis. We have one of them right here at -3. And then we have a second one right here at +3. Okay? Once you find those those zeros, you take that same zero. See how that's green -3 right there? I'm trying to cut out this little middleman step 2 factor here, and we're going to do synthetic division. Okay, take that same -3, drop it right there. Okay, now do you remember where the 1, the -7, the -9, and -18 are coming from? Those numbers that you see right there are coming straight from that original polynomial function right up there, correct? Yeah. So, when we do our synthetic division here, if all goes well, we should get a remainder of 0 there, which is what we get, right? 1 times -3 makes -3. Add that up, -2, multiply a +6. Add that up, there's -1, multiply a +3. A -6, a negative times a negative makes a +18, and sure enough, there's 0 for the remainder. Here's what happens next. They take this new now it would be cubic polynomial, which is this guy right here, and they do more division with that guy with your other 0 of 3. That guy right there. And if everything goes well, hey, that was my dog. Did you hear my dog? I think he's barking at some other dogs that are outside. And so notice what happens when they do the synthetic division again. Bring down the 1, multiply, 3 times 1 makes 3, add those up, get a 1, multiply, a 3 again, add that up, get a 2, multiply that out, 6, and then once again there's that remainder of 0. So what you're looking at right here, I'll highlight in yellow, after doing synthetic division twice, you're actually looking at this guy right here, which is a quadratic. And if we have a quadratic, we can find the roots there. We can't factor it, because there's no numbers out there that when you multiply them together you get 2 and then they add up to give you 1, so they had to use the quadratic formula. So that's what you're seeing right there. The b squared minus 4ac gives us a -7. You guys like those because there's no perfect squares that go into 7, so the only thing you could factor that square root of -7 into would be a square root of, say, -1 times a +7, and we should know by now the square root of -1 is just simply I, and then we still have that square root of 7 left over. So the two other roots that we have here could be -1 plus I square roots of 7 over 2, and then -1 minus I square roots of 7 divided by 2. So here's what that fundamental theorem of algebra states. Remember way up here, see the degree? The degree was 4, which means we're looking for 4 answers. There's 1, 2, and then down here using the quadratic formula, there's 3, and then there's 4. And there's step 4, them writing out all 4 of those answers. Okay? That's how that works. So, over here at this problem, here's what I want us to do right now. I would want to do this in stages, so definitely get the pause button ready. The first thing I want you guys to do on this problem is remind yourself of what step 1 is when it comes to trying to find all of the zeros. Okay? Here's the first thing I'd like you to do here. Do me a favor. After, take a second, look at the degree of the polynomial, and pause the video, tell the person next to you how many answers there should be to this problem. Go ahead and pause the video and have partners tell each other how many answers should this problem have. So how many should it have? You got it, because the degree is 4. There are 4 answers to our problem here. Okay? So now it's our job to go get those 4. Let me zoom out here a little bit. Okie dokie. So Since we are looking for 4 answers, what's step 1 of getting those 4 answers here? Step 1 to getting those 4 answers is now you doing what? Tell the person next to you, pause it again. What are you supposed to do first in your search for finding those 4 answers? So what'd you tell them? Did you tell them to use a graphing calculator and graph it? Then you are correct. Okay. Let's pause it again. Take the time. Type it into the graphing calculator. Graph it and find those real zeros. Alright, so if all went well and you graphed those real zeros, you should have had a picture look something like that. Going to your table of values, you should have gotten those 2 zeros. See them? -1 and +2. So in our quest for the zeros, all the solutions of zeros that we have so far is -1 and +2. Let me zoom out here. This is what we know so far. Okay, remember what we established first though. There are 4 solutions out there. So how do we figure out what the other 2 are? First off, do we know what kind of solutions the other 2 are? Do you notice that because the graph only crossed the x-axis twice, that means the other solutions have to be imaginary? Or, in fact, they have to be imaginary. They can't be irrational. So, what do we need to do now? You got it. It's time for synthetic division. Okay? Synthetic division is what we will use now to find those other zeros. And let's set that up and let's do that together here. Okay? Well, how about I do this? How about I pause it and let you guys set up the first division? Okay? Because I'll be interested to see which route you take here. Okay? So let's pause it. You guys set up the first division and then we'll check our answer. Okay. So there's mine. Take a look at yours. What'd you write? Couple of things. It is okay if you did not pick -1 first and you wrote the 2 first. Here's what's not okay. If you put 1 here, do not put the opposite number here. That's bad. Okay? Put the same number from the graphing calculator that you put right there. Okay? So that's mistake number 1 to look for. Mistake number 2. Did you put a 0 right there like you should have? Because remember, we have x to the 4th. We have 2x to the 4th. We have -3, x to the 3rd. But you know what's missing? Is we have 0, x squared now, don't we? That's why we need the 0 right there. And we have -1, x, and then -6. Okay? So that 0 needs to be there. So take a couple seconds, erase that, and get that fixed. Alright, time for the division. Right? If we do this division right, we should get a remainder of 0. So we bring down that 2. Let's multiply. That makes -2. -3 plus -2 would make -5. Multiply, and negative times a negative would make a +5. 0 plus 5 would make 5. We get a -5 right there. This looks good. -1 plus -5 would make -6. And a negative times a negative would make a positive. So 6 times 1 makes 6. And sure enough, boom, there's our 0. Okay? So, successful first synthetic division. Now, here's the next part. Mr. Cook is super lazy. And I've talked about that before. Well, actually, probably not with you guys, since it's the first time have heard from me. Do you notice what they did here? See how they did synthetic division here with the first factor? They wrote all that out, and they copied, you see what here is in this green rectangle? They copied that down, and then they did division here again with that one. Mr. Cook is so lazy with this synthetic division. Here's what I end up doing. I end up taking that quotient that I have right there and only using that guy and taking that second 0 of that +2, and seriously, all I do is I just drop that +2 right there and do the division again with those remaining 4 numbers that are right there. Now, if you didn't change your -1 and you start off with 2, of course you're going to have some different numbers here. But here's what I promise you. You put your -1 here this time, it'll work out and we're going to get the same thing at the bottom. Okay, so bring down that 2, multiply, there's a 4, add that up, I think we end up at -1, right? And then 2 times -1 would make -2. 5 times plus -2 would make -3. And then, I think here's a good thing. This is good. Watch this. 2 times -3, Gives me negative 6, right? I add those up, I get negative 12. You know what that tells me? It tells me I made a mistake someplace, right? Because don't we have to have that to be 0? Can you spot my mistake? Let's see here. Brought down a 2, right? So 2 times the 2 should make the 4. Negative 5 plus 4 should give me negative 1, right? Where is my mistake? Interesting. 5 plus negative 2, that should give us negative 3. Negative 6, we should have, if everything went well, we should have a 0 right there. Is anybody else pointing out this mistake that I'm missing here? Oh, I found it. There it is. That should be a positive 3, shouldn't it? 5 plus negative 2, silly Mr. Cook. That's positive 3, and then 2 times 3, shouldn't that make a positive 6? And then boom, that fixed it. See, take advantage of that fact that if you're not getting 0 there, it means something went wrong. And as you just noticed there, it can be sometimes tricky to figure out where that mistake was. And so now, after doing that synthetic division twice, this is where we're at right now. Okay, so let's take this. Remember, what we're looking at right here is we're looking at a quadratic, 2x squared minus 1x plus 3. The other zeros are there. And now it's our job to find those zeros. So I'll zoom out and we can adjust this picture. Alright, so here we are. Finally, 2x squared minus x plus 3. Sometimes in some of these homework problems you're going to be stuck in this position here, which unfortunately for us, we cannot take out a greatest common factor, so you know what we have left as our last resort here on this problem. That is the quadratic formula. So we will do the quadratic formula on this problem. First off, establish A, B, and C. So wouldn't A be 2 and B be negative 1 and C be 3? So the opposite of B, so that's why my first number that you see right about here is the opposite of negative 1. Okay? And then we have b squared minus 4ac, all divided by 2 times a. Remember that tip I gave you back in chapter 4? Figure out what b squared minus 4ac is first without the square root. Type just that in your calculator. Parentheses included. You're going to want that. Okay? And so then we do that, we get negative 23. Oh, awesome. I love negative 23. Reason why? No perfect squares go into 23. So this is a pretty simple negative radical to simplify, because pretty much all we have to do is take the I out of that square root and we can leave a positive square root of 23 right there. So now we have two solutions here. Our first solution would just be that 1 plus I square root of 23 over 4. And our other solution would be 1 minus I times the square root of 23 over 4. Those are our four solutions. Fundamental theorem of algebra, ladies and gentlemen. Great, right? Great. Nice work. Now, I'll stop this video here and we're going to do one more practice problem and we'll see how well we're doing with this.